Okay, worksheet 3 begins with being able to expand logarithms and being able to, when they're in expanded form, to condense them to 1. So just remember, anything that you're multiplying should be a positive in front of the logarithm. So in number 1, they're all pluses. Anything that's raised to a power, after you split it up as a product, so the log base a of 4 plus the log base a of x plus the log base a of y squared plus the log base a of z to the 4th, anything that's raised to a power, then that power also has to come out front. So that's why you'll see log base a of 4, log base a of x, plus 2 log base a of y, and plus 4 log base a of z. With 2, I had a few people with questions on that one. What I would do is first think of this as log base a of x to the 1/3, y over y to the 1/3, and z to the 2/3. So I always like to think of, get rid of any radicals, because we don't really talk about radicals with logs, but we do talk about exponents. So think of the cubed root as to the 1/3 power. So then I see that I have log base a of x to the 1/3, which means I bring the 1/3 out. In the denominator, so that's why these are both minuses, I have 1/3 log base a of y, and then a minus 2/3 log base a of z. So that's probably the easiest thing to do, is get that into exponential before you try to expand it. Number 3, we have to bring the 1/3 up as a power, so it's log base a of x to the 3rd raised to the 1/3 power, so it's just the log base a of x. We have to bring this 2 up, so that becomes y squared. I left the negative there for now, and then I bring the 2 up here to make that x squared. Now I see that this is the minus, so that goes into the denominator when I combine these. These two are adding, they're positive, so they stay in the numerator. So when I have the log base a of x plus the log base a of x squared, it's log base a of their product, x to the 3rd, and then it's over y squared because that was negative. This one, again, you're subtracting two logarithms, so it's the log of their quotient, but you should see that x minus 3 is going to end up canceling after you factor it. And so you really have log base a of x plus 3, but you should make a note that x can't be 3, because if it were 3 in the original problem, even over here, if you look at the original problem, you'd be taking the log of 0, and you can't do that. So just so you realize, you probably should put that restriction in there as well. Okay, and then we got two equations again, so this is similar to what you did on worksheet 2. Remember, two kinds of equations, one where you're going to see that you have a number involved, which means you want to combine the logarithms. So like in 5, you combine the logarithms. Once you get a log equation where a log is equal to a number, you put it in exponential. So 3 to the 3rd equals 5x, and then you solve it. So that's the one kind of log equation. Get the logs on all one side, use your properties of logarithms, and then go to exponential. Same with 6. You see the log of a sum of two logs. You write it as the log of a product. Then put it in exponential, solve it. But remember, you have to plug these back in. And this one I plugged in -4. If I plug in -4 in either of those, I would end up getting a negative. You can't take the log of a negative. When you see one like an 8 similar to that as well, 8 actually already is just a logarithm, so 5 squared equals 4x minus 1. When you get to 7 though is a little different. You can have a bunch of logarithms, but there's no number by itself. So then you can take this 3, make it an x to the 3rd. You're adding two logarithms on this side, so that's log base 2 of 2x cubed. And now you have an equation where you have two logarithms equal. If two logs are equal, then what you're taking the log of has to be equal. So 2x to the 3rd equals 8. Solve for x, and again, just make sure up here in the original problem, if you put that number in, you wouldn't be taking the log of a negative. Number 9 and 10 are both ones where you have a log equaling a number. So you just put it in exponential. So this one's a common log, 10 to the 1st. Solve that equation to undo a square root. Don't forget that you square both sides. When you get your answer, you get square root of 101, but it's plus or minus. And again, just go back up here, but if you're going to square it, it doesn't matter if that's a positive or a negative, you are going to get the log of a positive number. 10 is log base e. It's natural log, so e to the 0.5, which means square root of e, equals 3x minus 1, and then you just solve for x. Okay? All right, on the back, same thing. Quite a few equations to look at. This one's in log form, so put it in exponential form. It's an ugly number, but you can do that, and then just subtract 5. This one has two logarithms together, so you have to combine them with a number over here. So combine these two to get the log of x plus 9 over x. Then put it in exponential, 10 to the first equals that, and solve it. 13, you have two logarithms and a number. So again, use your properties of logarithms. It's the log of their product. Put it in exponential, 3 squared equals that number. It's a quadratic, it factors, but -6 does not go back in there. 4 does. 4 gives you logs of positives, but -6 does not. 14, be careful of 14, the x is right here. It is not in a logarithm, it is not in a power of an exponent, so just solve for x. Add 7, divide by 2. That's all you have to do with that one. 15, we have logarithms on this side, so we can combine them as the log of their quotient. It equals a log over here, so again, if the logs are equal, those two things have to be equal. And then we solve, we got -1/2, but if you put -1/2 back in, you'll get it the log of a negative, which means then there is no solution. 16, similar to that, you have logs, natural logs everywhere, so you had to use your power property. That was the log of x to the -2nd. This would be x plus 1 to the 3rd equals natural log of x plus 1. If I combine these together, I'm going to get x plus 1 to the 3rd over x squared, because that is a x to the -2nd power. What I ended up doing, because I knew this was 1 over x squared, and this was an x plus 1 cubed, and this was an x plus 1 to the 1st, I actually put those together. So I subtracted the natural log of x plus 1 cubed, which meant I could write it as a division, as a quotient, because now one of the x plus 1's canceled, so it made it a little bit easier. Some of you were trying to distribute out an x plus 1 cubed, and it got pretty long. If you see that you have some like bases, do that to save yourself some time. So then I cross-multiplied, I solved to get -1/2, and again there was no solution, because if I plug it back into the original problem, it's a 0. These last ones are all exponential. When you have an exponential function, you need to get the base by itself, so always do that first. So I had to divide this one by 5. Then if it's an exponential and the variable is an exponent, you need to put it in log form. So log base 4 of 10 equals 3x. And then I just need to divide by 3. Same with 19. 19 got ugly, but you still had to divide by 500. Here's my variable, so I have to take log of this base, so log base this of this fraction, which reduced, I reduced it, equals the exponent 12x, and then I divided by 12. So it got fairly ugly. Now you could take this whole thing and divide by 12, so I could have written it as all of this divided by 12. That's correct. But then I used change base again and said that means it's the log of this fraction divided by the log of that number, of that base. So I actually used change of base to make it look nicer when I wrote it. But you definitely could just leave it like this, divided by 12. And same with 20, log base 4 of 100 equals x squared. So I don't know what the log base 4 of 100 is, but I can take the square root of both sides, and I get plus or minus the square root of that logarithm. And then the only other one that you didn't need log for was 18. Make sure you look where the x is. The x is here. It's not as an exponent. It's not within a log. So to solve for x, you just undo. Divided by 4. I took the square root of both sides, so I just was left with what's under here equals plus or minus the square root of 7. Then I subtracted 2, and then I multiplied by 4. So if the variable is not part of an exponent and it's not within a logarithm, you don't need logarithms to solve. Okay, so just be careful of that. All right, so remember, two kinds of equations. When you're dealing with logarithms, if there's two logs in a number, you're going to combine those logs, put it into an exponential. If you have logarithms, all of them logarithms, you just want to get the two logs equal to each other, so then you can set the two things you're taking the log of equal to each other, as long as the logs have the same base. Okay, that's worksheet number 3.